Hello, it's me, and as we're rounding out our corner turning series / tutorial, as we explore the two different types of corner turners, dinos and skewbs. Dinos, of course, having no corners but edges, and turn about the corner like so. And then you've got the skewbs where you actually have corners and centers, and these turn by dragging the corners with it, as well as the center. So you turn about an axis, which takes the corners that go around a center corner. Slightly different in form, but the solutions and the turning, actually, the algorithms, the down, down, up, up is the same. Because really, what it comes down to is instead of taking 90 degrees between each turn, they're both 120 degrees. We just have to kind of vary things a little bit. And I did go through the strategies of various different types of skewbs, whether they're super skewbs, so to speak. But now it's time to take both of our corners and put it together into both of our corner turners and put it together into one single true hybrid puzzle. In which case we get this guy over here, the Dino Skewb. Let's move these guys back out here again. So just like a dino, it has dino cuts over here, where if you look at all of these as corner slices, or rather edge slices over here, it moves just like a dino. And it can move like a dino in all directions, basically, just like this. So I could I'm perfectly fine to scramble this and solve it as a dino. But we can also take deeper slices. You've got this more superficial slice as a dino, but I can do a deeper slice as a skewb. So these are skewb slices over here. And in that, it means that these corners together move along with it, with the center corner, and these will be the centers over here. So basically, in that way, it moves exactly like a skewb over here. Now this is a true hybrid in that it doesn't have just characteristics of one or the other. It actually has exactly the same identical moves as both at the same time, which does make for interesting solves. Well, I'd shown you the F Skewb before. Now the F Skewb was kind of like this. It was sort of midway between both of these guys together and a full hybrid, in which case with this you do have these cuts that look the same, but you also have a fully reduced slice over here, a fully reduced corner over here. So you have a superficial turn over here, slice over here, which is pure dino, and then you can actually do a skewb slice over here. Now you can do that with 1, 2, 3, 4 slices. Here you can't do a dino slice because these aren't reduced down or fused to 1, but you can only do skewb slices over here. So basically, in that way, the F Skewb was kind of a semi-hybrid, that the only dino turns that you can do were these guys, but they're non-overlapping. So here's a dino turn, here's a dino turn. I can't really scramble this as a dino because, well, these don't intersect each other. It's almost like moving the caps of a Pyraminx. However, I have to say that it was this little puzzle, this cute little puzzle, that really defined the strategies of some of the more complicated hybrid puzzles. So when first using and trying to solve the true Dino Skewb, it can be difficult because as you're reducing areas, you kind of forget what goes where, but I started to solve all of my hybrid puzzles based upon the form of the F Skewb, including this guy over here, which is a combination of a dino with dino cuts over here and a 2x2 with 2x2 cuts over here. And what I would do is I would reduce these puzzles to something that looks a lot like the F Skewb, where you end up with non-overlapping areas here. I also showed that this F Skewb has a lot of homology with this guy. This Dian Gem 5 is actually really an F Skewb, and it has the same homologies and can be solved pretty much the same way, even a little bit easier. But in any case, as you may not have a lot of opportunities to see a puzzle like this, let's roll out another one just for comparison. This is the Master Skewb. So this is the higher layer version of this guy over here, where it turns on the corner. So too, this turns on the corner with a center corner over here. Then it moves these corners about the axis with it. So in that way, this is just like a normal skewb. But you have this other slice over here. So this is one slice here, this is the end slice, but you get this third slice here too. So it's like a 3-layer skewb, whereas this is just a 2-layer skewb over here. can only move 2 down in that axis. This is a 3-layer one. Well, although the form of this looks very similar, it's actually very different kind of puzzle, solved very differently. It's true you can move this like a Skewb, just like you can here. So I can move this like so, and I can move this like so. So these are both Skewb cuts, as it were. But the other difference is that this center is part of the center Skewb, and this over here also has an edge, but it's a very different type of a shape. And because you might not have a lot of opportunities to see these together, I'm just going to demonstrate some more aspects here. I'm just doing very different types of middle slices here. You can see where the middle slices go across here, that this is very close to the end, just with one corner. This is also close to the end with one corner, but actually together they make a reduced corner. So this is sort of a point-by-point comparison, but despite the fact that they look alike, they're solved very different. They're very different kinds of puzzles. In other words, it's more like convergent evolution, the fact that they look very much like each other. You see I have one centerpiece here surrounded by these guys. You have a centerpiece over here. Then you've got this guy, which may be somewhere in between the two. So just wanted to roll that out, as it's not a usual thing to see these kinds of puzzles and forms together. Some more little tricks here. Now, bring this all the way down, why not? Bring this all the way down, why not? And bring this all the way down, why not? So you can see how they all move of their own accord. Now the movement of this is pretty rigid, and as you recall, I had a hard time getting this to go quite how I wanted it, quite how I like it. So line these up together here. Okay, so on to strategy, how to solve this. Well, what I've taken to do, the way that I solve this over here, is actually by multiple reductions. Because once you scramble this, you're going to see that it's very hard to know what goes where. And at first what I tried to do is reduce it to a bunch of dino slices, but it really was getting a little confusing trying to keep track of everything. So what I'm actually going to do is reduce this to the F Skewb, where I have here and here that are reduced, and then here and here. So I'm only going to reduce 4 corners before I reduce these guys over here. So 4 corners are going to be reduced. Then what I'm going to do is reduce the centers. Now I'm not going to reduce all 4 centers. I'm just going to reduce these 2 because I'm going to make it look exactly like an F Skewb. So I'm just going to reduce these two, so that they're adjacent to the corners that are reduced. So I'm going to take this, reduce it to an F Skewb, and then reduce that F Skewb portion to a Skewb, and then solve it as a Skewb. So it's a multi-reductive process from here to here, from here to here, and then solve it as such. So why don't we go ahead and try. What I'm going to do is just start off with a scramble just to demonstrate. By doing both Skewb moves and Dino moves, it's causing a really hopeless mishmash of all different aspects of the puzzle. So here, the thing about this puzzle is, although it moves as a Skewb and moves as a Dino, you don't solve it like any one of them in particular. You solve it in kind of a unique way. Now, once doing the solve of this will actually act as a guide to the solve of another kind of a puzzle, which is another homologous one. So as you can see, we're getting it all jangled up. I'm just going to keep going with this until I really enhance the challenge. Hocus pocus. Okay, pretty good. Right now I have a very intimidating looking Dino Skewb scramble. So, how do we make order out of this chaos? And I gotta tell you, this one really kind of gave me a run for my money. This one was kind of a difficult one until you kind of got the strategy of it to see what might be the best way to put this in. So, what I'm gonna do first is I'm gonna convert this into the form of an F Skewb. Because if I can do that, I know I can solve an F Skewb, which will further be reduced to Skewb, and I know I can solve a Skewb. So I'm going to pick 4 corners at random that I'm going to reduce first. And, well, by convention, let's try the green. So I see a green over here, green and red. So I'm going to put another green one in. Now, it can't just be any green. I can't put a green and another green and red across from there. If I do a green and orange, I've got to make sure that it's not 2 colors adjacent each. It's got to be two colors adjacent each other. If I put the wrong green, I'm going to have two colors that should be opposite each other, adjacent to each other. So here's a green and red. I don't think I'm going to want to use the green and orange. So let's do a green of some other color. Well, here's a green and blue, and this I can easily just do a Dino move. And by the way, when I do moves, I'm going to call this a Dino move and this a Skew move. So I'm going to Dino this into here. Okay, no problem. Green, I need the red and blue. So where's red and blue? Red and blue is going to be somewhere along here. So here's red and blue. So I'm just going to do a Dino here and Dino there. Okay, so I've got this one reduced, no problem. Now the next one that I'm going to reduce, the centers of the Dino slices that I'm going to put in right now are going to be non-overlapping. So this is going to be the center of this Dino slice over here. So the next Dino slice will be here because it's not overlapping to here. In other words, I'm turning it into the F Skewb here and here, as these are non-overlapping. So I'm going to go ahead and put this one in, and it's going to be green also. So let's find another green. Here's a green and orange. Dino this in, then move this up. And I'll just Dino this down so it can match up here. So now another green, but I got to be careful because it can't be a green with any of these colors. It's got to be a different one. How about this green and white? Sure, but which one? This green and white or this green and white? Well, it's going to be the green and white that can find a Dino move that can come into here. So it's obviously going to be this one. So what I'm going to do is Dino this here. Now if I Dino it from here, it's going to offset this. So let's do it this way. Move it like so. Blast this out of the way. Move it in. Okay, these two are in here, over here. And we can move this up. Now, look what happened here. This got reduced. But I'm going to ignore that. Why am I going to ignore that? Because it is a complement of this. It's exactly the same. And that's where I was running into trouble. I'd say, oh good, well this is reduced too, but this is green, blue, and red. I've already got a green, blue, and red, so that's only going to confuse. So I'm going to ignore that. It's not in the right place yet. I want to put it non-overlapping. So I'm just going to turn this here, and I'm going to find the white and orange. Yeah, orange. White and orange. No, that's white and yellow. White and orange must be here somewhere. It's right over here. So I'm going to Dino this here and Dino this there. Okay, so this is what I wanted. I've got this reduced and this reduced. And they're at two different non-overlapping areas. And these colors don't really run into each other. Now understand with this puzzle, if you notice at the beginning, it's not the classic Rubik's color scheme, which was a little bit confusing. But anyway, this is going to be the red side, this is going to be the orange side, so that's normal. This is going to be the blue side. Normally green is opposite blue, not in this case. This will be the blue side, and this will eventually be the white side over here. So now what do we do? Well, I'm going to want to put in another Dino corner that's not overlapping with these, so that's going to be this over here. So what's going to go here? Well, I did the exact same strategy, remember, with this guy, with Super X. So this is going to be the orange and blue. So I'm looking for an orange and a blue, and it's right over here, all ready for me, orange and a blue. So I'm going to find another, say, blue, right over here. Now, let's see which one we want it to be. So this is blue here, orange, and orange. The color that's going to be here is going to be opposite green. In this case, it's not going to be blue, but it's going to be the only one that's left over that we haven't used yet, which is going to be yellow. We haven't used yellow. We got blue here, white's going to be here, orange is going to be here, green is going to be here, must be yellow down here, which means that I'm going to look for, say, an orange and yellow or blue and yellow, and we have an orange and yellow. So I'm going to move this in. Now it's going to butt up against this one, so I'm going to move it in. Then I've got to turn it and move it back out. So I'm going to Dino this down, move it back out. All right, so far so good. Now I'm just looking for the blue and orange right over here. To get this in, it's going to be the same thing. I'm going to end up moving this out for a second, but that's okay. That's why it's good to do this non-overlapping stuff. It's just easier to visualize. To start off with, turn, move this in line, and bang. Okay, so this is all in. This is good. This is good, and this is good. I've got it lined up. Now here's the fascinating thing about this strategy. Here's the fun thing about this strategy. Now you're probably thinking, okay, now I've got the fourth one to do. But here's what's neat. Once you get the first one, second one, and third one in, the fourth one automatically gets solved. So you don't have to do a thing. For some strange and magical reason, when solving this puzzle, putting in the 3 reduced corners of an F Skewb, or the 3 reduced Dino corners, this fourth one will automatically be put in. And that speaks to the parity of the puzzle, meaning it has no choice but to be solved. These 3 simply can't be solved without this being solved. So that work is done. So what we've done is we have the corners of our F Skewb finished. But we're not done with our F Skewb reduction, because now what we have to do is reduce the centers. We need to go from 4 centers to 2 centers, which means we have to reduce these guys. So what I'm going to want to do is I'm going to want to have the same color in right underneath one of these reduced corners here. So I don't want these 2 to be of the same color because it's not by a reduced corner. I want these 2 to be of the same color that's by a reduced corner. So it looks just like this. Now to those that saw the F Skewb tutorial and even the Diane Gem 5 tutorial, this is done pretty much exactly the same way, and it's not unlike reducing the edges of large puzzles, large cubes. What I'm going to do is I'm going to look here, and I want to put a blue one into here. So now, the other thing to bear in mind is when I've got these reduced, I'm free to do any Skew Move, and it's not going to mess these up. So it's just not going to mess it up, so I don't have to worry about that. When I do a Dino move, it could mess them up, but Skew Moves will just rotate these around because they're non-overlapping. So I can do anything I want here. So I've got this blue, and I want to put it here so that it's just above one of my reduced corners. Now, as you recall, when I did that, I would move it into here. Then what I'm going to do is I'm going to take this center, move it down here, replace this center here, move this back up, and then Dino it back. But what I'm also going to do now is I'm going to separate the layers. So I can move this down here. You can see this is in. Now I don't have to move this entire center down like this. Instead, all I need to do is move this portion over here, because I'm going to come to a time where I'm going to have this solved but not this. So what I'm going to do is when I put this in here, this is going to move down to here, and that's going to be with a Dino move. A Dino move will move this down to here. Then what I'm going to want to do is I'm going to want to, once it's down here, I'm going to want to replace it with a center on this side. So I'm really oscillating between these centers here. So this comes down over here, but to substitute it with this layer, I have to do a Skew Move. So basically what it's going to look like is this will come down, I'll Dino this down, I'll replace it with this with a Skew Move, then I'll Dino it back up. That way I don't touch these portions over here. So the other thing to bear in mind too is I'm replacing it with this area here. But just to demonstrate, I'm going to move this down like so, so this is in. Then I'm going to do a Dino move down, and then with this center, this pulls in. So I'm going to do a Skew Move. Just move this layer down like so. Then I'm going to Dino it back and pull this back. At the end of the day, this is all fine, and back here we have our reduced center over here. But I can make it even more clever than that. Here's a orange one and a red. Let's say I want to put the orange here. So I'm going to find an orange. I can maybe just tip this upside down. I'm just going to move it around here, turn and turn. And not yet. So it's really just a matter of positioning. It's really no huge deal here. Now I don't have to move these centers together. With these Dino moves, I can move them independently, so it's really not going to cause much of an issue here. So I can move this here. And what I'm doing is I'm trying to move an orange one. It doesn't have to be. I could move a white one into here also. Let's maybe actually do that. Turn and turn. Okay, this white one can join this over here, and it's just below a reduced corner. So this can come down like so. I just have to bear in mind what I'm going to be substituting. These centers are all going to participate. This, if I'm going to work on this layer, this one is going to Skewb down to here. Then the Dino move is going to replace it from here. Then it's going to Skewb its way back. Now let's take a look at what's going to be replaced with what. This is going to come down here. I'm basically going to substitute this for this. which means if I coordinate it right, I can maybe put this one in too. This is going to end up here to be brought back up to here, and this is going to end up here to be matched with whatever I put down on this side over here. So wouldn't it be great if I can put a red one here, because then I can solve this one too. I can reduce that too. So let me just go like this, bang. So now what's going to happen is this is going to come down here, this will end up over here, and to be a perfect threesome, so to speak, is if I had a white one that was over here. Or if I had a blue that was over here, rather, because this blue, when it comes down, is going to come back up to join whatever is going to be replaced over here. So ideally, we'd have a red and a blue, and I'll just kind of look around to see if I have something like that. I've got a red and a blue together, and I don't, so I'll just be happy with this, happy getting two. So I'm going to take this and cut down with this dino over here, do a dino cut down here, move just this layer down to this side, so that's going to be a skew move down to here. It's down here, I'm going to substitute it with this, so we'll do a dino move down here, then we're going to skew it back, and then dino it in. And sure enough, I've reduced this, and I've got a reduced white over here. So I'm going to keep following suit with that. I'm just going to keep finding opportunities. This is already in, so we don't want that. Move this over here. Now, this is not actually reduced. It's not reduced because it's by a corner, dino corner, that's not in, that's not reduced. So, let's see. Again, this isn't reduced here, but this is. And I'll turn this here and here. Okay, so here's a yellow. This yellow can come into over here. So I'm going to be using this. I'm going to move it down with a dino, which means I'm going to be skewing this down here to substitute for it up here. So I already like where this is going because this yellow is going to end up here to join with this, and it'll reduce this. Now if I only had a white over here, then it would be perfect because it'll join with this white. Do I have any yellow and whites? And I don't. So that's okay. I'm going to move this down here to put this in, dino it to the bottom, skewb it to substitute it with this layer, dino it back, and now bring this back up to solve that. So this is good, and then I put this one in over here. All right, let's see what else we got. See what else we can do. Now let's see, we've got green one over here. Now I can remove this green one here and maybe put it up there because remember, this isn't reduced. I'm free to do dino moves with that. So this will guide me which dino moves are safe and all skew moves are safe. So I'm going to turn it down here, here, here. And now I put this in line to come down to here. So let's see what has to happen over here. Well, it's going to come here, do a skew move here, so it's this side that I'm looking for, and I'm looking for an errant white one. Well, this looks pretty good because this blue is going to come down and then back, so what I'm looking for is a white and a blue. I have that here. So we have the possibility of doing something really neat. Move this up here and move this up here. Okay, so let's reason out what's going to happen. This green will come to join here. This white will ultimately end up over here to join this white, and this blue will end up over here to join this blue. So I'm going to put 3 in with 1 turn of this commutator. So move this in over here, skewb it down, dino this to bump it out of the way, skewb it back up, and bring it in. Dino it back up. Lo and behold, this is good, and this is good. So I put 3 in. So we can quickly make short work of this as we keep going. So this is all in. Okay, so this can come down to here. I don't want to move this out, but that's okay because I'm isolating it to this layer here. So this red, well actually this orange will come here, but this is already reduced. I want to move this one in place. Let's see if I can do that. Turn, turn, and turn. Okay, these two are protected. This is over here. This will come join this over here. Okay, this will dino down to here, and this will skewb down to here. This is already reduced, so I want to move this out of the way. This is already reduced, so that's no good. And we'll move this up and down and around here. Okay, now let's see what's left over. Wouldn't it be great if I can put to here a red one to match with this? And there must be a red one that's out. There is, unfortunately, it's this one, so I can't use that. So when I put this over to here, wouldn't it be great if maybe I had a yellow that I can put in? Well, actually, this is yellow. If I had a red that I can put in. So is there an errant red? And the answer is no. So this is going to do some shuffling around. I'm only going to be putting one in. So I'm going to turn this over here, brings this in, Dino it down here, Skewb this in to replace it, Dino it back, move it in. Okay, so now we should be down to just a couple, perhaps just 3. 1, 2, and 3. So this should be interesting. Let's see what we can do. Let's Skewb these into place, keeping track of what we're doing. Okay, so this is free to join over here. And this is going to flip-flop with these centers here. So whatever's going to come into this area here, I'm going to put to the side where this is going to come down, and it's going to flip-flop with these centers. So what's the other one that I have left? Other one that still needs to be reduced. Everything else seems okay. It's this one over here. So I'm just going to move this into place. Now I'm going to put this in here. This will Skewb down to here, and this will join this over here. Now this should work out perfectly because this red is going to end up here to join this red. This orange is going to come over to here, basically to join this orange. So this should put the last 3 in. This is just in a different perspective here. So I'm going to turn this like so. Then I'm going to Skewb it down, Dino it down, Skewb it up, move it in, and lo and behold, all this is done. So all of these have now been reduced. What I have, actually, right here is I now have an F Skewb. I've reduced it to that.